Hello everyone, welcome back to the operating system class. So now we are going to discuss about the time sharing systems. So in previous class we have discussed about the batch processing systems and also multi-programming system. So the main aim of this batch processing is reducing the CPU idle time. Okay, and the multi-programming system, the resource utilization is very much more. So that is very the motive of the multi-programming systems. Now we are going to discuss about the time sharing systems. See, in an interactive computing environment, the user submits the computational requirement that is called sub-request. So whatever the user which submits the request, that is called sub-request. Okay, so the sub-request which is to process that particular program or process that particular event to examine its response on the monitoring screen. Okay, so a time sharing operating system which is designed to provide the quick response to the user sub request. So sub request is nothing but the user request which is submitted by the user. Okay, so in this the main aim of this time sharing system is to provide the quick response to the user sub request. Okay, so to achieve this goal by sharing the CPU time among the process in a such a way that each process to which a sub request has to be made in turn, the CPU without much delay. So the whatever the process which is available to ready to use the CPU, which in turn the CPU which will be allocated to the each and every process. Okay, so the scheduling techniques were used by this time sharing kernel which is called the round robin scheduling and also a time slicing. Okay, so we know that the round robin scheduling is nothing but, so if, before going to see that round robin, first scheduling is nothing but selections of the program, the next program under the CPU execution, that is called scheduling. Round robin is nothing but what? So it which in turn provide the CPU. Okay, depending on the arrival of the response, the CPU will be allocated. So it is in turn round fashion. It will be allocate the CPU in a round fashion. So that is called round robin scheduling with the time slicing. Time slice is nothing but the predefined time which is allocated to each and every process. If the predefined time is over, if it is not executed completely, then the particular program which is preempted from the CPU and again it is put back to the queue. So that same CPU which will be allocated to the other process. Okay, so this is called time slicing. So always the CPU, I mean the scheduler will select the head of the queue, the request, whatever the request which is there in the head of the queue, that will be selected for execution because it is in round robin scheduling. Okay, now the always kernel which maintains the scheduling queue, which maintains the scheduling key. I will tell you what is that. Scheduling queue which maintains and if the time slice elapses, if the time slice is over before process completes servicing of the sub request, the kernel preempts it and moved it to the end of the queue, and then scheduler schedules the another process implemented through a timer interrupt. Okay, I'll tell you this through the diagram. So the time slice is nothing but what? The largest amount of the CPU time any time shared process can consume when the scheduled to execute an CPU. The largest amount of time is allocated to the each and every process under the CPU execution, to execute under the CPU. That is called the time slice. Predefined time is allocated to the each and every process for CPU execution. See here, always the kernel which maintains the scheduling queue of a process that wish to use the CPU. Okay, so these are the process is ready to use the CPU. So among these process, the scheduler will select one of the program. So that one of the program, always the scheduler will select the head of the queue. Okay, so when the scheduled process completes and servicing of a sub request or the starts an IO operation, the kernel which removes that particular program from the queue and schedules the another process. Such a process would be added at the end of the queue when it is when it receives a new sub request or when its input output operation completed. Okay, so which in turn in circle fashion the CPU will be allocated to each and every process. Okay, so the scheduler always select the head of the request, head of the queue request. So that selected process which is given to the CPU for execution. Once the time slice is over, the predefined time is over. If it is completed, the complete computations operations are over, then that particular sub request is sent for the IO operations, or otherwise that will be removed. Again it is put back to the queue. Okay, so this queue also contains a process finishes the input output operation or new sub request is made to it. So all the process will be available in the queue. It's ready to use the CPU. These all the process are ready to use the CPU. Okay. So this arrangement which ensures that all the process would suffer equal delay before getting to use the CPU. So each and every process will get the equal delay before going to use the CPU. Okay. Now the response time. So that response time would be decreased. I mean the response time would be degraded if the process consumes too much of CPU time in servicing its sub request. Okay, so the response time will be poor. It affects when it consumes the more CPU time. Okay, so the kernel uses the notation as time slice to avoid this kind of situations. Okay, so that's why here we have used one more concept as time slice. That is, the time slice is denoted by delta. Clear? So this is all about the schematic of the round robin scheduling with the time slicing. So here we are using the two techniques, that is round robin scheduling and the time slicing. So without time slice we cannot achieve the good response time. So that's why the kernel which uses the one more concept which is called the time slice. Okay, now what do you mean by time slice? Okay, actually the largest amount of the CPU time, already we know that, already we have talked about this time slice, that largest amount of the CPU time any time shared process can consume when scheduled to execute on the CPU. So that is called time slice. So it is denoted by delta. So if the time slice elapses before the process completes the servicing of the sub request, okay, so the kernel preempts the program and move it to the end of the scheduling queue, and the scheduler schedules the another process. Okay, so the preempted process would be rescheduled when it reaches the head of the queue once again. Okay, now how to calculate this response time and also the efficiency? Okay, so to measure the response time, measures of user services, we know that the user service can be measured using the response time. Okay, so it is nothing but the time taken to service the sub request, that is called response time. So this can be estimated by, okay, now I have a n number of users. Okay, so the user, I mean the number of users using the system at any time n. So at any time I have a n number of users. Okay, n number of requests. Okay, and the delta is nothing but what? The delta is nothing but the time required to complete the sub request. Okay, the servicing of the each sub request that requires exactly delta time, delta CPU seconds. So this much of time which is required to complete the CPU, I mean complete that particular request. Okay, and the sigma is nothing but scheduling overhead. Okay, and this that means the CPU time consumed by the kernel to perform the scheduling. Okay, and neta is nothing but a CPU efficiency. So based on that, I can calculate the response time is equal to the n number of users, n number of requests multiplied with this much time required to complete the CPU operations plus overhead. scheduling overhead. So this is my response time. Similarly, I can calculate the efficiency. Efficiency is equal to delta divided by the delta divided by delta plus sigma. That is the time which is required to complete the CPU operation divided by the sum of CPU time plus overhead. So this is nothing but efficiency. How much it is completed, consuming the time to complete the CPU with respect to the overall time taken to complete that particular operation. So that is called efficiency. Okay, but the actual response time would be different because some users may be inactive. So it is waiting for the some activity. I mean the some response need to be complete, waiting for the some events to be occur. So that time some of the users will be in inactive mode, and some program may require the greater CPU time than the actual CPU time. Okay, so because of that reason the response time may differ. And so this is the example for time sharing systems. See, in scheduling, in the queue I have a two response, I have a two request, that is P1 and P2. So these are the two sub requests which I have in the queue at the time t equal to 0. Okay, so always the scheduler will select the head of the queue. In the head of the queue, P1 will be available. So the P1 will be selected for the execution. So scheduled program is P1, and the remarks, the P1 is preempted at the 10 milliseconds because the 10 milliseconds of time which is given, the CPU delta time which is given, time slice is given 10 milliseconds. So once the 10 milliseconds is completed, then it is removed from the CPU and again it is put back to the queue. So initially at the time T0, the P1 is selected for the scheduling. So I have in a queue only P2. Okay, so the P2 will be in the head of the queue. Again the P1 is preempted, so again it is also added to the queue. Okay, so the P1 is also added. Now the P1 will be in the head of the queue at the time T is equal to 10. So the P2 will be selected for the execution. So the P2 is preempted at the time T is equal to 20 because the 10 milliseconds of time. So the next 10 milliseconds CPU time is allocated to P2 execution. Again the P2 is also removed and again it is put back to the queue. Now once the P2 at the time T is equal to 10, the P2 is selected for the scheduling, the P1 will be in the head of the queue. Okay, so the P1 which come under the head of the queue, and the P2 also preempted, it is again put back to the queue because it has not completed the complete CPU computation time. So at the time T is equal to 20, again the P1 will be selected for the scheduling. Okay, selected program P1. So the P1 has started the input output operation as 25 milliseconds. That means which uses the CPU for only 5 milliseconds of time. So that CPU computations are over. So it is start using the input output operation at the time 25 milliseconds. Okay, so in the P2, so the P1 is completed the CPU execution. So in the queue I have only the P2 value, P2 request. So okay, at the time T5, at the time T is equal to 25, I have only one request, P2 request. So that P2 will be selected for the scheduling. So the P2 is preempted at 35 milliseconds of time because the 10 milliseconds which is allotted to the each and every process, right? So after the 10 millisecond, from 25 to 10 millisecond is nothing but 35 milliseconds. So 35 milliseconds is allotted the CPU for P2 execution, and that will be preempted. Again only the P2 will be available in the queue at the time T is equal to 35. Again the P2 will be scheduled because there is no other process or the request in the queue. So the P2 starts input output operation at the time T is equal to 45 milliseconds. So this is also completed the computation, CPU computation. So it starts the IO execution at the time of 45 milliseconds. So at the time of 45 there is no request in the queue. So the queue is also in empty and scheduled program is also not selected. The CPU will be in idle mode. So here the graph is given, the CPU activity P1 and P2. So initially the P1 which executed on the CPU for 10 milliseconds, and then P2 will be executed 10 milliseconds. Again the P1 will be executed on the CPU for 5 milliseconds and P2 will be executed for 10 milliseconds, and again the P2 will be executed for 10 milliseconds. And the IO activity, when I come to this IO activity, the P1 which uses from at the time 25, at the time 25 to the more time the IO activities are takes place. Similarly, the P2 which takes the IO operation after the time t is equal to 45 milliseconds of time. Okay, so this is the one of the examples of time sharing system with the techniques of round robin and also a time slice. And here we have one more concept which is called swapping. So what do you mean by swapping? Swapping is nothing but the techniques of temporarily removing the process from the memory of a computer systems. Temporarily removing the program from the computer system, that is called swapping. Okay. So for example, in the memory I have a two program. So it is nothing but the kernel memory I have a two programs P1 and P2. Now I want to schedule the P3 at the time T1. At the time T1 I have the two programs P1 and P2. Okay. Now the kernel wants to schedule, the kernel wants the P3 program need to schedule. So there is no space in the memory. So during that time the kernel, the operating system need to perform the swapping operation. Okay, some of the program temporarily removing the memory, and that particular program which is stored into the temporary storage. In that free space, whichever the program which is required, so that program which is stored into that particular memory, that is called swap in and swap out operation. Swap in is nothing but loading the program into the memory, and swap out is nothing but removing the program from the memory. So that is called swap in and swap out operation. Okay, so now which program will be removed from the memory? So the program which will be selected, so that particular program will not be scheduled in nearby future. That kind of programs are selected for swapping. Okay, so that particular programs are removed from the memory, and that program will be stored into the temporary storage. Okay, so whichever the required program, that will be stored into the memory. Okay, for example, here the P2 will not be scheduled at nearby future, so that P2 will be removed from the memory, and P3 in that particular place P3 will be loaded. Okay, similarly again after executing this, the P4 which is required. So the P4 in these two programs, the P1 will not be scheduled at nearby future, so the P1 will be removed, and in that place the P4 will be loaded in that particular place. So it is called swap in and swap out operation. Similarly, if you see in this D diagram, P1 and P3 will be available. So the P3 need to schedule nearby future. So the P3 will not be removed from the memory. P4 is removed. In that same place, the P1 again it is loaded. Okay. So this is called swapping operations. So the kernel which performs the swap out and swap in operation. Next is real-time operating systems. See, in real-time operating system, which operates based on the timely manner with respect to the time constraints. Okay, so in this the classes of application which is called the real-time application, the user needs the computer to perform the some actions in timely manner. So why it is in timely manner? Because to control the activities in the external systems or to participate in them. Okay, so the timeliness of action is determined by the time constraints of external system. So according to this I can define the real-time application. So a program that responds to activity in an external system within a maximum time determined by the external system. So within the maximum time that particular external system must respond for the event. So this is called the real-time application, the real-time operating system. So if the application takes the long time to respond to an activity, then there is a possibility of failure may occur in an external system. So to avoid that, we are using here the response requirement and also a deadline. So the response requirements is nothing but it can use the maximum amount of specified time. The system to indicate the largest value of response time for which the system can perform the function perfectly. It can use the maximum amount of time which is specified, but within the time it must respond for the activity. If it is exceeds, there is a possibility of failure may occur. So the particular activity or particular response may not exceed this response requirement time. Okay, so for example, from the satellite sensor to the ground station. So the satellite sensor will send the information to the ground station at every 2 milliseconds of time. The 500 samples will be sent from the satellite to the ground station at every 2 milliseconds of time. So the ground station, whatever the sample which is received, that will be stored into the some other place and wait for the another response. Wait for the another samples to receive. Okay, so that ground station must respond for another 2 milliseconds. Within a 2 milliseconds, it must respond for the another sample. Okay, so in here, the response requirement time is nothing but 1.99 milliseconds we can consider. So within that, it must respond for the other activities. Second sample, ready to receive the second sample. If it is not ready to receive the second sample, then there is a possibility of failure may occur. It may lose the second sample, not ready to execute the, not ready to receive the second sample. There is a possibility of losing that sample. So that's why it will not exceed that response requirement time. Okay, so that is called response requirement, and deadline is nothing but the actions in the real-time application is the time by which the action should be performed. So this is the time by which the action should be performed. Within that particular time, the action must be performed. Okay, so for example, in the same example itself, if the new sample is received from the satellite at the time t, okay, so the deadline for storing into that particular sample into the disk is t plus 1.99 milliseconds. So within that, it must respond for the next sample. So the deadline is equal to t plus 1.99 milliseconds. And these kind of real-time operating system which is used in missile guidance and also the command and controlling applications like on the process control, air traffic control and data sampling and data acquisition systems, like on display the system in automobiles and multimedia system applications, and then ticket reservations and banking systems. So these all those places the real-time applications are used. And so based on that, we can classify the real-time system into the two types. One is hard and also a second one is soft real-time systems. So the hard real-time system that meets the response requirements under all the conditions. So it will not be exceed the response requirement time. So always for all the activities, it must meet the response requirement time for all under all the conditions. If it is exceed, there is a possibility of the large damage will occur. Say for example, in air traffic control and then ground stations. So in the air traffic and then ground station, it will not exceed the response requirement time. If it is exceed, there is a possibility of the control signal may change, mislead the pilot, the traffic signal, the controlling signals. So there is a possibility of huge damage will occur. So such kind of systems are called the hard real-time systems. So it is typically dedicated to processing the real-time applications. Okay, and then soft real-time system, it makes the best effort to meet the response requirement of a real-time applications. It will put the effort to meet the real-time response. The real-time response requirement time. If it is not achieved the response requirement time within that, it cannot complete. So there is no problem. So that particular output may be considerable. So there is no the huge damage in the activity. For example, in reservations and also the ATM machines transactions and all, if it is exceed that limit, there is no damage, there is no huge damage will occur. So that kind of outputs can be acceptable. So that kind of systems are called the soft real-time systems. So it cannot guarantee that it will able to meet it. So they meet the requirements in the probabilistic manner, and the example is multimedia applications. Okay, so what are the features of the real-time operating system? So the essential features of the real-time operating systems are concurrency within an application. So within an application, there is a parallel operation, concurrent executions may take place. Okay, within one another, it may execute concurrent operation. The OS consider the executions of such part of the process. Okay, so the next is the process priorities and scheduling. So the process priority, first we'll see. The process priority, a programmer can assign the priority to the process. So the numeric number which is assigned to the each and every process. And scheduling. So the OS uses a priority based or the deadline aware scheduling. So in this real-time operation, always which performs a priority based and then deadline aware scheduling. Okay, and then domain specific event and interrupt. The programmer can define the special situations within an external system as a event and associate the interrupt with them and specify the event handling actions for them. So the domain specific event and also interrupt. If there is any event which is occur, immediately it will send the handshaking signal. That is, the interrupt will be raised for that. Okay, and predictability. So the policies and then overhead of the operating system should be predictable here. And reliability. So we know that the reliability, the OS ensures that an applications can continue to the function even when the fault occurs in the computer system. If there is any fault occurs, the operating system can continue the function. So how the functions can be continued based on the two techniques, the fault tolerance and also a graceful degradation. So what do you mean by fault tolerance? So the fault tolerant, the computer system uses the redundancy of resource to ensure that the system will keep functioning even the failure is occurs. Okay, and then graceful degradation. So here, if there is any fault occur, immediately the function will not be drop out, which will not come to zero. It is reduce the functionality, reduce the speed of the functions. Okay, once the errors are rectified, again it is back to the normal execution. So that is called the graceful degradation. Because of these two techniques, the operating system, the real-time operating system can achieve the reliability. Okay, so this is all about your time sharing systems. The next is the distributed operating system. The distributed computer system is consisting of the several individual computer systems connected through the network. So in the network, the number of computers are connected. Okay, so that each computer system may be a PC or the multi-programming system, or it may be unclustered. So the many resources of a kind exist in the system. There are multiple resources which exist in the system. When compared to the single system, in a network the multiple computers are connected. So when compared to the single system, here the multiple resources are available. So this feature which is used to provide the benefits of the more number of benefits. We'll tell you the what are the benefits of this distributed computer systems, distributed operating system. So handling the network or the individual computer, if there is any failures occurs, that requires the special techniques. Okay, so the individual computer, if it is fails in a network, so in a network the number of computers are connected like this. If any one of the computer which fails, then the special techniques is required to rectify that. And to use the resource, if there is one computer system it fails to use the execution. Okay, so immediately that particular computer, the particular operation which will be switched to the another computer system for execution. Okay, to switching between the one to the another, it also requires the special techniques to access the kinds of resource over the network. Now, the benefits of the distributed operating systems. So, the benefits are resource sharing, reliability, computation speed up, and communication. So, these are the benefits of distributed operating systems. Now, what do you mean by resource sharing? So, the resources can be utilized across the boundaries of individual computer system. So, in a boundary, what are the computers are connected? So that can share the resource among them, among the network. Okay, so the individual computer system which is connected to that. So if the PC or workstation can use the resource that, for example, such a printer or over the LAN, or that can be accessed the specialized hardware and software resources. So that can be used among the computers which is connected to that particular network. Okay, and reliability. So the OS continues to the function even when the computer system or resource in it fails. So if it is fails, the one computer system it fails, immediately that function which is switched to the another computer system for execution. Okay, and the computation speed up. So the process of an applications can be executed in different computer system to speed up its completions. Okay, so the one applications can be divided into the number of parts, and each parts can be executed by the other computers which is connected to that particular network. So to increase the speed of the computation, okay, and communication. So the user can communicate among themselves irrespective of their locations in the system. Irrespective of the locations, the computer can share the resource, can communicate the informations between the computers, between the clusters in a network. Okay, so these are the benefits of distributed operating system. According to that, I can define the distributed system is nothing but a system is consisting of two or more nodes, where each node is a computer system with its own clock and memory, some networking hardware, and a capability of performing the sum of the control functions of an operating system. So the network which contains the number of nodes, that each node, it may be on computer system or it may be on cluster, whatever it may be. So that each computer system which contains the clock, memory, and also a networking hardware, and then capability to perform the controlling functions, okay, of an operating system. So this is called the distributed systems. So the some of the key features of this techniques, the distributed operating system, the techniques which is used in this distributed operating system. One is the distributed control, second one is transparency, and third one is remote procedure call. So what do you mean by the distributed control? So the distributed control is nothing but the control which is distributed among the computer system which is connected in a network. Okay, your control function is performed through the participation of several nodes, possibly all the nodes in a distributed system. So in a distributed system, in a network, if the number of computers are connected, so that control will be distributed among the nodes which is connected to that network. So that is called the distributed control. And transparency, the resource or services can be accessed without having to know its locations in the distributed system. Without knowing the locations, it can access the resource or services can be accessed in a network. And remote procedure call, RPC, it is also called as RPC. So the procedure call, a procedure that is located in the different computer systems. So the RPC is analogous to the procedure or the function call in a programming languages, except that the operating system passes the parameter to the remote procedure over the network and return its result over the network. So this is called the remote procedure call. So this is all about your the distributed operating system. So in a summary, in this unit, we have talked about the computation environment is consisting of the computer system and its interfaces with the other system, and then what are the services which is provided by its operating system to the user and also a program. With the evaluations, the computer technology, the batch processing system, multi-programming system, and time sharing systems are also discussed. Okay, so in batch processing system, the CPU time must be reduced, the idle time must be reduced. That is the main motive of this batch processing system. And multi-programming, the priority based schedulings are used, and the main motivations of this multi-programming system is increasing the resource efficiency. And time sharing operating system, which here we have used the concept which is called the round robin scheduling and also a time slicing. Similarly, in real-time operating system, we have executed like the priority based scheduling and deadline aware scheduling. Okay, and the next we have talked about the distributed operating system. So in that, the resource will be shared among the computers which is connected to the network. So these are all the things which we have discussed, and also the one more operating system which is there, that is modern operating system. In the modern computing environment, has the elements of all the classic computing environments. So it uses the different techniques for the different applications. So whatever we have discussed, everything which is available in this modern operating systems. Okay, that's all about the classes of operating system. I hope this video is useful for you. We'll meet you in the next video. Thank you all.